So let's start. So in the last class, we did this formula. Okay, if enthalpy of formation of the products and the reactants is given, you can use this formula. There's this other formula, which is that this other formula is for it's about the Hess law again. कि उसमें था कि if enthalpy of combustion of everything is given, enthalpy of combustion of the products and reactants is given. So उस case में what would you do in that case? कि you've got W plus X and the two reactants are reacting to produce these two products, Y and Z. And in this case, if you know the enthalpy of combustion of the reactants as well as the products, so you know delta HC of Y and you know the delta HC of Z as well. So what do you do in that case? So in that case, the formula, the enthalpy change of this particular reaction, whatever that reaction is, the reaction, it doesn't matter what the reaction is. In this case, the enthalpy change of the reaction is going to be, it's going to be the enthalpy of combustion of your reactants minus the enthalpy of combustion of our products. So in this case, it's going to be the opposite. So you have two formulas. One is product minus reactants, but that is when enthalpy of formation is given. The other one is reactant minus products if the enthalpy change of combustion is given to you. Okay, so these are your two formulas. And that's it. For this, you don't have to draw this entire Hess cycle. So the formula is again conditional, only works under these few conditions, that if either combustion is given or either all the products is given. So we're going to do some questions for this. So last time we did do formation ones, and now we're going to do I'm going to try and see if I can find the combustion ones. For example, this one. If you look at this question, he's saying what is the enthalpy change of formation of propanone? So this is propanone C3860. So enthalpy change of formation is when 1 mole of propanone is formed from its constituent elements. And the elements in this case would be carbon, solid, and hydrogen would be gas. And the other element would be oxygen, which would be gas as well. This is going to be half O2. This would be 3H2 and 3C. So that's a balanced equation. So he's asking you to find the enthalpy of formation of this or the enthalpy change of this particular reaction. And what information has he given to you? He's given you the enthalpy of combustion of hydrogen. So you know this value. Delta HC is given. Its value is known. The enthalpy of combustion of carbon is also known. So delta HC of carbon is also known. The enthalpy of combustion of propanone is also given to you. So you know that value as well. The enthalpy of combustion of oxygen is 0 because oxygen, burning in excess oxygen would give you oxygen. So there is no reaction happening. So the combustion of oxygen is always 0. So आपको ये सारा दिया हुआ है. You're given the enthalpies of combustion of the reactants as well as the enthalpy of combustion of the product. So all you have to do is, the formula is, okay, if the enthalpy of combustion of the reactants and the products both are given, then the enthalpy change of that particular reaction is, okay, you sum up the reactants and subtract it from the products. So this is exactly what we're going to do. So the reactants So the overall enthalpy change of this reaction would be the reactants are 3 Cs. So that's minus 394 into 3. I mean, we've got 3 carbons. 3 hydrogens, that's minus 286. And again, it's going to be times 3. So that's my reactant minus the product, the enthalpy of combustion of the product, which is minus 1786. तो ये जरा बताओ कि क्या आ रहा है इसका? What is the value that you're getting? ठीक है, Oswa. That is fine. And let's try and find another combustion one. ये सारी formation है. So anyway, so the thing is that enthalpy of formations are given for the products as well as the reactant. So all you have to do is, what are the enthalpy of formation? It's going to be delta HF of products minus the delta HF of the reactants. That would give you the enthalpy change of the reaction without drawing the Hess cycle. So in this case, the product is Fe is going to be 0. And Al2O3 is given as minus 266. So my product is 0 and minus 266. That's Al2O3. So that's my product. And the enthalpy of formation of, actually it's not, usse likha hua is that aluminum oxide is this one, minus 1676. So it's minus, and minus the product. Sorry, minus the reactant, which is FeO, which is this one, minus 266 times 3. And Al is 0. You can remember elements, the enthalpy of formation of elements is always taken as 0 because you don't have to form elements. So product minus reactants, if enthalpy change of formation are given. And reactant minus products if combustion is given. What is the answer for this one? ठीक है, B minus 2474. It's D. It is a different क्यों आ रहे? One second. Isa dekh lo कि is it this becomes plus, it's going to be minus 1676 and this would become plus 266 times 3. Okay, make sure be very careful with the sign. So okay, it's B. So most questions are going to be solved in this manner. Enthalpy of formation of water is given. Enthalpy of formation of H2O2 is given. So it's going to be, so this one is going to be product minus reactants. Again, so the questions are going to be very simple. Just do product minus reactants if enthalpy of formations are given. So 2 water molecules, that's your product. So the product, 2 water molecules, that's minus 285.8. And they're 2 water molecules, so that's my product. Oxygen is 0. The enthalpy of formation of oxygen is 0. Minus the reactants, which is 2 H2O2. Hydrogen peroxide, that's minus 187.8 times 2. So what do we get for this? This is got CF. And let me just find another. Again, it's they're just asking for the expression. So enthalpies of formation of MgO is given, KCl is given, and KClO3 is given. And for Mg, the enthalpy of formation is 0. Elements is always 0. So product minus reactants. So the product is 3 MgOs, that's 3 times minus 602. The other product is KCl, which is minus 437. make sure you put brackets minus the reactants. Be very careful with the sign. The reactant is KClO3, so that's minus 391. And इसके हिसाब से पता नहीं कौन सा होगा. It's going to be 3 times. It looks like this one. Okay, this is the expression that we are getting. So most of these questions would be very, very simple. So you just have to find out ये combustion वाला है. Combustion वाला कर लेते हैं कि if enthalpies of combustion is given for the carbon is given, for hydrogen is also given, and for C4H10 is also given. So in this case, it's going to be reactant minus products. Reactant minus products. So the reactants are 4 carbons and 5 H2. So 4 into minus 394. The other reactant is 5 H2. So that is 5 times what's H2 minus 286. So that's my reactant minus my product. The product is C4H10, which is minus 2877. So what do we get for this? We get B. ठीक है. So for this, it's coming out to be B. So let's move on. Most of these questions would be very simple. All you have to do is remember this. Okay, agar formation is given, just do product minus reactants. And if combustion is given for everyone, then do reactant minus products. And be careful, don't forget to multiply with moles, because enthalpy of combustion and enthalpies of formation are given for 1 mole. So in your equation, if there are 2 moles or 3 moles or 2.5 moles, multiply it with the moles. So don't forget to multiply with moles. ठीक है, is this clear, Sidra? Oscar, is this clear? Amna?
Yes.
Acha. Then the next one is the last one. That is again also simple. Okay, the only thing is drawing the Hess cycle. That's difficult. Okay, the other things are just apply formulas and you get the answers, but the formulas are conditional. Okay. Just a second. Let me. अच्छा, अब ये कि the last one is the experimental method, which is which you're going to do in the lab as well, and it comes in your paper as well. And that is Q is equal to MC delta T. It's small m actually. So MC and small t as well, small c as well. So Q is equal to MC delta T. So that's a formula that you've studied in O-levels as well. It's calculating the energy change of a reaction if you know the specific heat capacity. So it's the experimental method of finding you do an actual reaction, you measure the temperature change. And when you measure the temperature change, you try and figure out the energy of the reaction. So the first thing is, remember one thing, that whenever you're trying to, in most cases, whenever there's a reaction happening anywhere, the reaction usually happens in solution. On planet Earth, the solution is mostly made up of water. 70% of the Earth's crust is water. Like if all the reactions that are happening in the human body, in the cells, in the blood, etc. I mean, 70% of the human body is water. If there was no water, particles would not have been able to travel around. and there would have been no chemistry happening. If you go to the Sahara Desert, there is no chemistry happening. There are no reactions happening. Why? Because if one particle wants to react with the other particle, it should be able to move around. So water enables that. It enables particles to sort of float around, move around, which is why reactions are possible. So if there is no water, most of the chemistry will not happen around you. There are no reactions happening on Mars or on the moon because the particles can't move around. So it's a simple concept. So the thing is that when you try to calculate the enthalpy change of a reaction, what all reactions are happening in water, and they're transferring their energy to water. Most of the time, they're transferring their energy to water. So, like if you get sick, your temperature rises. So there are probably some reactions that are happening, and most of the energy gets transferred to all the water molecules that are in your body. So in a way, you don't actually measure the enthalpy change of the reaction. Indirectly, you're basically measuring how much energy is being gained by the water, or how much energy is being gained by the or lost by the water molecules. So the energy would be produced by the reactions that are happening in water. So water, so we're going to assume, first thing, let's talk about assumptions. So even if there are a bunch of molecules that are reacting with each other, so the assumptions are, we're going to assume that most solutions are mostly water. And you're basically measuring the energy that is absorbed by the water or released by the water. So all energy of reactions gets transferred to water. So just remember, the main assumption is, in most reactions, you're going to take specific heat capacity of water as 4.18 joules per gram per Kelvin. That's the first thing. You're going to assume that specific heat capacity C is water. The thermometer is measuring the temperature of the water. The delta T would also be of water. It would be the temperature change of water that you would be measuring. And where is water gaining or losing all that energy? It's basically gaining it from the reactions that are happening inside it. So you're going to measure the temperature change of the water. If the temperature increases, that means the reaction is exothermic. Why? So you have to, don't forget to put a negative sign. If the temperature decreases, then it's going to be endothermic, which means whatever reaction is happening is basically taking in energy. So remember one basic assumption, and that is, and also the mass. So we've talked about mass. And since water is the one that's absorbing or absorbing all the energy that is coming from the reaction, the thermometer is measuring them. So the mass would be the mass of water as well. So you're gonna use the mass of water. So every time in most reactions that are happening in solutions, the specific heat capacity is taken for water. I mean, we ignore whatever particles that, just ignore the particles that are taking part in the reaction. You're measuring the thermometer is measuring the temperature of the water. So specific heat capacity is taken of water. Delta T is taken of water as well, the temperature change that's happening to water. And M is the mass of water that you're using, because all the energy is going indirectly to water. So the mass of water is very easy to measure because water has a density of 1. So which means that if it's 1 cm cube, then that's equal to 1 gram. If it's 100 cm cube, density of water is 1, which indicates that whatever the volume of water is, the mass would be exactly the same. So the density of water is in grams, it's 1 cm cube per 1 gram per cm cube. अच्छा तो ये सारा याद रखना है, ठीक है? The main assumptions. Ignore so any reaction that's happening is basically happening in water, and you're measuring the energy, the experimental energy mc delta t of water. And where is that energy coming from? It's coming from the reactions. Okay? Is this point clear?
Yes.
So I'm going to jump right to the questions because you just have to use Q is equal to mc delta t. So most of the questions are going to be pretty straightforward. So this one. So let's start off with the first question. He's saying that in an experiment to calculate the enthalpy change of combustion of a fuel, 1.5 grams of the fuel was used to heat 200 grams of water. So there's a fuel that's burning and it's producing heat, and he's heating water using that fuel. And the water is 200 grams. And he's burning how much fuel? He's burning 1.5 grams of the fuel, which is 0.0326 moles. He's burning that fuel. And all the energy is being transferred to, it's being transferred to water. Okay, so water is absorbing that. And the temperature of the water rises from 25 to 55. So delta T is 30 centigrade. And remember that temperature change in Kelvins and centigrade is the same. I mean, 25 to 55 is the same in Kelvins. It's the same in centigrade. So you don't have to convert temperature. The fuel specific heat capacity of water is also given. That's 4.18. So that is C. He already gave us that. And he's saying, so the first thing is we're going to figure out how much energy is being absorbed by water over here. So I'm just going to use Q is equal to mc delta T, which is going to be 200 times 4.18 times delta T, which is 30. So ये क्या आ रहा है? And I'm also going to add K. What I'm going to add over here is okay, this is in grams. C is always taken as, unless otherwise specified, it's going to be joules per gram per Kelvin. And delta T is taken officially in Kelvins, but it's going to be the same in centigrade. So you don't need to convert this. I said, did anyone calculate this? What do we get for this? I said 24,600. So we're getting, so that means the amount of energy that is the heat that is being produced, that's 2460. Get that 24600. You just did mc delta T and you figured out the amount of heat being produced by this fuel is 24600. So you burnt 0.0326 moles of the fuel. That's the amount of fuel that was burnt. And it produced this much amount of energy. And since the temperature was rising, it's exothermic. So you have to put a negative sign. अच्छा एक और चीज इसमें ऐड कर लूं कि the energy that you're going to get is going to be in joules, because your specific heat capacity is also in joules per gram per Kelvin. Now, the next part is he's asking the significant heat loss, therefore the experimental value is different, etc. Use the information. What is this experimental value for the enthalpy change of combustion? Now remember, whenever you talk about enthalpy change of combustion, that is for 1 mole of a substance burning. So we would have to apply ratios over here. What we would have to do is, okay, what's going here is that this suggests that 0.0326 moles burns, and it produces how much energy? It produces minus 24600 joules of energy. So we would have to use ratios, because enthalpy of combustion is always for 1 mole. So use ratios and tell me what would be the energy change if 1 mole of the fuel burns. So it's going to come out to be, if you use that as X and cross multiply, it would come out to be minus 24600 divided by 0.0326. Using ratios. So what do we get for this? Just saying, what are you getting? You're getting I think it should be a more exact value. I mean, you're right, but I don't know why. Is the first one correct? Just a second. Let me use a calculator. It should be an exact value. Just a second. 200 multiplied by 4.18. Actually, he told us to use 4.18. So 4.18 and times 30. Is it 30? It is exactly 30. So we got, it was 25080. And then when you divide by 0.326, you're going to get 769,325. And that's kilojoules. Sorry, that's joules. And also remember that most enthalpy change questions, they deal in kilojoules. I mean, they can deal in joules, but most of the time they deal in kilojoules. So most of your formulas, like Q is equal to MC delta T, is giving your values in joules, but your enthalpy change questions, they usually deal in kilojoules. So over here, he was asking for kilojoules. So all you have to do is you have to divide this by 1,000. You're going to get 769 kilojoules. How did you figure out it's negative? It's exothermic because the temperature was rising. Whenever temperature is rising, that's an exothermic reaction. So I'm just going to repeat this. Okay, the whole thing is, okay, you've got, he heated 0.0326 moles of water. So he burned a fuel and heated this much amount of water. Temperature rose by 30. And the specific capacity 4.18, you did Q0 to MC delta T, and you got minus 25080 for this. Up here, he was asking for enthalpy of combustion. We learned that enthalpy change of combustion is for 1 mole. So 0.0326 moles would produce this much energy, which is minus 25. So it's going to produce this much energy. So 1 mole would produce how much? So वो आपने figure out करनी है. Is this question clear?
Yes.
So the remaining questions are going to be pretty simple. Most of these questions, a few tricky ones, but most of them would be very, very straightforward. So where it's exactly the same question. They don't have a variety of questions for this. So again, it's 0.47 grams of a hydrocarbon that's burning. So that 0.47 hydrocarbon burns. And when it burns, what does it do? Again, you've got 200 grams of water. That 200 grams of water is heated, and the temperature rises by what amount? EK, what is 41 minus 23.7? What do you get? 17.3, yes. So delta T is 17.3. And so you can, using this, you can use Q is equal to MC delta T. So it's 200 grams into 4.18 into delta T, which is 17.3. And its temperature rising, so it's going to be exothermic, but he's only asking for the amount of energy that is absorbed by the water. So that's it. That's about it. So remember, no need for conversion. It's going to be C. So this question was just Q is equal to MC delta T. That's it. This question is exactly the same thing, except that you're given a table now. You can find delta T. The temperature is rising again. So delta T is 33, I think, in this case. And he's saying how much energy went into the water. That's again. So mass of glass beaker plus water and the glass beaker. So you subtract that. So the mass of water is going to be 100 grams. So all you have to do is, you know, this is 100 grams. You know, the temperature changes by 33 Kelvins. So khali kya karna hai ke Q is equal to MC delta T. That's 100 into 4.18 and times 33. That's about it. कि भाई water में कितनी energy absorb हुई है. तो क्या है हमारे पास? ठीक है. This is coming out to be B. Now, here's another interesting question. Maybe they'll sometimes they'll link it up with moles. So इसमें क्या है? What he's doing is, अच्छा इसमें बल्कि let me add this point over here. I told you this thing. I told you that the mass of water is going to be, if it's 1 cm cube, it's going to be 1 gram. If it's 100 cm cube. Now remember this thing. There's a small point, and that is, if two solutions are mixed together for a reaction, so here's my tiny beaker here, and and here's this other tiny beaker. So what you're doing is you're pouring two solutions into this bigger beaker. There's NaOH, let's say 40 cm cube. And there's HCl here, which is let's say 10 cm cube. Now both of them are poured into this larger beaker. So remember this, and you have a thermometer added, and you're trying to measure the temperature change of this. I mean, you're trying to measure what is the energy change for the reaction when these two things are mixed together. The first thing is, always remember, when you're trying to mix two solutions, तो उसमें क्या होता है कि the first thing that happens is the volumes get added up. So the total volume of the final solution is going to be 10 cm cube of HCl plus the 40 cm cube of NaOH that you're adding. So it's going to be 50 cm cube. And since every solution is mostly water, so the mass would be taken as approximately 50 grams. So remember this thing. Whenever you're mixing two solutions together and their volumes get added up, because the two solutions are going to react, but their volumes are going to get added up. So the volume of the final solution would be 50 cm3. जिसका temperature measure करोगे, that would be 50 cm3. Is this point clear?
Yes.
So in this question over here, he's saying 25 cm3 mixes with 25 cm3 of hydrochloric acid. जिसका मतलब है the final thing that you have is actually 50 cm3 of solution, and that's basically equal to 50 grams because water has a density of 50. So 25 and 25 cm3 of this solution, they mix up. So the first thing is, if you're doing Q is equal to mc delta T, the mass is 50. There's going to be a thermometer added, and he says the temperature rises by 2.5. So I know delta T as well, which is 2.5. And he specifically told us that the specific heat capacity that should be taken, I mean, we were taking 4.18, but in this question, he's saying take it as 4.2. So I can measure Q is equal to mc delta T, which is going to be 50 grams multiplied by 4.2 multiplied by 2.5 kelvins. So what do we get for this? Just a second. It's a 525. And it's going to be minus 525 because the temperature rose. So it's an exothermic reaction. It's in joules, remember that. What is the molar enthalpy change of the reaction? Now remember, when he talks about molar enthalpy change, he basically wants the energy change for 1 mole. So the first thing is we need to figure out what was this energy change. How many moles were actually taking part in the reaction? So this is a question about moles as well. So पहले तो moles निकालो कि भाई how much NaOH did you use and how much HCl did you use? That's going to be 25. What's the formula of moles? Concentration times volume. So it's going to be 25 times 0.35 divided by 1000. So how many moles? So what is this energy change for how many moles? So how many moles are you getting for this? So ये आ रहे 8.75 into 10. Okay. So it's coming out to be that it's for 8.75 times 10 per minus 3 moles of NaOH that's reacting. So we got this much energy. So he was looking for molar enthalpy change. And remember, most of the questions they're looking for molar enthalpy change. So most of the questions at the end of the day, you would have to use this ratio. तो इतने मोल्स के लिए इतना आया तो आपके पास 1 mole होता तो फिर कितनी एनर्जी चेंज होती. So use ratios. So it's going to come out to be minus 525 divided by this thing, which अगर x के लिए solve करोगे, it's going to be minus 525 divided by. So what value do you get? ठीक है, and that is in kilojoules. the chances of error are that Q is equal to mc delta T is always in joules. Mass should be taken in grams. Specific heat capacity is also in joules per cm cube per Kelvin. And temperature is taken in Kelvins, but delta T doesn't really matter. You don't need to convert this. And you have to be careful about the answer. Most of the answers would be in kilojoules, so you would have to do that conversion, extra conversion. But most of the questions are going to be fairly straightforward. So I'm going to do this. I'm going to give you a slightly more difficult one. It's exactly the same. I mean, they don't even have a variety in this. Most of the questions are exactly like look at any question. They don't have, it's the same thing. There's a hydrocarbon that's burning. So this one is just very slightly tricky. So I'm going to post this in the group. As I've posted this question in the group, try and send me the solution for this specific one. ठीक है, बाकी सारे question exactly उसी तरह. It's the same thing repeating over and over again. So try and solve this question, and I'm going to send the worksheet as well. ठीक है? Then here, let's continue next time then. Okay, everyone. Take care. Allah Hafiz.